exponential functions. Yeah. Application word problems. So this page that you're looking at here, how to choose what formula to use. This is a nice indication to tell you what formula you're using, especially with word problems. So here we know exponential is y equals ab to the x, where a is your initial amount, your starting value, whether you have growth or decay, either 1 plus r or 1 minus r, and then the x represents your time. Words that indicate what function to use. All right, these are your key words for. These are your key words for figuring out which one to use. Okay, so for increasing, for growth, it's either a percent increase, it's appreciating, or it's growing. If it is a decay, it would say percent decrease, or it's decaying, or it's depreciating. Okay. So those are the three that we're going to look at, today, days before. It just helps you out. Simple interest and compound interest, I'm not going to get into that this lesson, but both of these will be part of this unit in the coming days, I think day 5. So we'll take a look at these the next lesson. Okay, so we're on day 4. So now it's applying what we know with exponential functions, how they work, and now we're going to take it to word problems. So, number 1. In 1995, there were 85 rabbits in Central Park. Let me pull out a highlighter. 85 rabbits in Central Park. Okay. The population increased by 12% each year. How many rabbits were in Central Park in 2005? Okay, so let's think about this. This increased by 12%. That piece there, that should definitely tell us that this is exponential because it's a percent, right? Anytime we see percent, that is exponential. It's a growth. And what is 12% as a decimal? Well, again, it's just 12 divided by 100. And if you do that with your calculator, you would see that 12% is 0.12. Right? So it's an increase, it's a growth of 12%. Okay? Now, it says in 1995 there were 85 rabbits. So if we're looking at the exponential equation, if we have y equals ab to the x, right? ab to the x. Try and think about what is this 85 rabbits. Back in 1995, this is your initial value, your starting value, your A. Okay? It increased by 12% each year. And how many rabbits were there in 2005? Starting in 1995, it's asking how many rabbits are in 2005. What is the difference there? How many years has it been? Well, from 1995 to 2005, that is 10 years. So we just found our x too. Right? That's our x. So let's fill in the equation. Y equals, my initial value is A, so 85. My B, again, it's either 1 minus or 1 plus r to the x. And again, r is our percent. If it's an increase, it's going to be plus, right? The population's increasing. So I'm going to have 1 plus my decimal, which is 0.12. So 1 plus 0.12 to the x power, and we determined that x was 10 years. So let's rewrite this as y equals 85. 1 plus 0.12 is 1.12 raised to the 10th power. And again, calculator. Pull out your calculator. This is exactly as you will see how you should put in the calculator. 85 parenthesis 1.12, end parenthesis, raised to the 10 power. And what we get there is y is equal to 263.997. Okay. Now, little footnote. What did we just find? We found how many rabbits there were in Central Park in 2005. 263.99. Okay, we are working with a living, breathing object in this case. So, I'm not going to round up to 264. I didn't hit that number of rabbits. Anytime we're working with living, breathing objects, you round down. So put this little side note. Round down for living, breathing things. Okay, you round down for living, breathing things. So my answer here would really be 263 rabbits. Okay. On to number 2. There are 500 rabbits in Lancaster on February 1st. Let's get the highlighter back out. 500 rabbits on February 1st. If the amount of rabbits triples every month, it triples every month, write a function that represents the number of rabbits in Lancaster after m months. And then it wants us to find how many rabbits are there in Lancaster on August 1st. So again, what are we working with? That's my first question. Is it linear? Is it exponential function? Keyword, triples every month, right? That means, hopefully you see, it's going to be exponential, and it's growth because it's tripling every month. If something is tripling each month, it's getting 3 times as big, right? So in this case, when we fill in our formula, it's going to be 3. I'll explain why. Okay, so we know it's exponential. What do we think this 500 is? That is A. That's our initial value, our starting value. So let's get this down. Y equals AB to the X. Do we know what X is? We can figure it out. How many rabbits are there in Lancaster on August 1st? And we started on February 1st. How many months has it been? Well, February to March to April to May to June to July to August, 6 months. That tells me that X is equal to 6. So, filling this in, Y equals 500. Now again, if it triples every month, that's like a 300% increase, right? 300% increase. And again, 300% as a decimal is 3. So that's my B. 500 times 3 to the X, which we found out to be 6. Okay. Straight into the calculator as you see it. And it would give you an answer of 364,500. What is my units here? Rabbits. We're looking for rabbits again. Okay. So this is the key piece here, this 3. Because it's 300%. If you guys are confused on why it's 3, make sure you ask me in class. Okay. Number 3, I want you guys to do by yourselves. Do number 3 by yourself. Make sure you actually do it with work. I'm going to check this for your grade tomorrow. This is the one I'm checking along with another one. I will give you the answer, but I want to see all the work. Your final answer should come out to 5,000 Okay. Number 4. Let's see. Let's go to a different pen. Purple. In 1985, there were 285 cell phone subscribers. Pull out the highlighter. In 1985, there were 285 cell phone subscribers. Now, the number of subscribers has increased by 75% per year after 1985. How many cell phone subscribers were in the town in 1994? It gives us everything we need. First off, is it exponential or is it linear? Hopefully you see the percent increased. This is exponential. Is it a growth or decay? Well, the increase tells me it's growth. What is my decimal for 75%? Again, divide by 100, and you will get 0.75. Okay. Initially, there were 285 cell phone subscribers. That's my A. And how many years has it been? 1985 to 1994. Subtract those two. And you would see it has been 9 years, which is my X. Alright, so we have everything we need. Y equals AB to the X. Y equals, my A is 285. My B, if it's a growth, I'm starting with 1 plus whatever the decimal is. 1 plus 0.75. Raised to the 9, because X is 9. Okay, let's simplify that a little bit. Y equals 285 times 1.75 to the 9. And that, put it straight in the calculator, would be equal to 43,781.98. Okay, how many cell phone subscribers were there in 1984? Again, always round down for living, breathing things. So it's not going to be 782, it's going to be 781. I'm rounding down. So the answer is 43,781 cell phone subscribers in 1994. Went from 285 to 40, almost 44,000. That's a huge increase. Number 5. I'm just going to skip. Number 6, I want you guys to also do by yourselves. I'm going to check it. Do number 6, get your answer. The answer that you should get is 51.2 milligrams. Okay. Back page. I'm going to go through number 7 and then quickly go through the rest. Ryan bought a new computer for $2,100. The value of the computer decreases by 50% each year. So it decreases by 50%. He bought a new computer for $2,100. Decreases by 50% each year. Now the question's asking, after what year will the value drop below $300? So typically it gives us the years, right? What am I looking for? Highlighter. It typically gives us the years, but here it's saying after what year? In other words, it's not giving us X in this case. This is a new type of question that we haven't seen yet. It's not giving us X. It wants us to find it when the value will drop below $300. So first off, let's figure this out. At linear or exponential, well, it decreases by 50%. That's going to be exponential. My initial value is 2,100. If I'm decreasing, this is a decay of 50%. which again, always write it as a decimal. 50% as a decimal is 0.50. And I need to figure out what is x. Well, let's set up our equation. Y equals AB to the x. So y equals, A is 2100. It's a decay, so I'm doing 1 minus 0.50 to the x power. And then I'm going to simplify that. Y equals 2100. 1 minus 0.50 is 0.50 to the x power. And again, we don't know what x is, right? This is what we're trying to figure out. What is x? That's our unknown number of years. Okay. So for this, there's no miracle way to get it. It's just trial and error. I got to figure out what is that value. I want to test in a few different x values. It's really not that complicated. Use trial and error. In other words, you want to plug in different numbers for x. Okay? That's all this is. I'm trying to figure out what this is when I'm going to be below $300. So whenever y is below $300, when I'm substituting in these different values, that's going to tell me what is my x. So, how do we do this? You must show 2 wrong and 1 right trial for full credit every time you have a question like this. You must show 2 wrong and 1 right. So 3 total, so 3 different x values. 1 of them should be right. So let's take a look at what I mean. Let's try x equals 1. So I'm going to do y equals 2100 times 0.5, and I'm going to do y is equal to 1. If I do this, if I put this in my calculator, I will get 2050. And again, I'm looking for where it's going to drop below 300. Is this below 300? Definitely not. So x is not going to be 1. Let's try x is equal to 2. Y equals 2100 0.50 squared. When x is 2, the answer you would get is $525. Again, that's not going to work. So we have 2 incorrect. Hopefully x equals 3 is the correct one. 2100 times 0.50 to the 3rd power. And that gives you 262.5. Okay? So, after what year will the value drop below 300? Well, after year 3, it dropped below 300. So the answer is x equals 3 years. Three years. Kind of backwards type of question. Number 8, you can do yourself. I'll give you the answer. Comes out to $6,656. Okay, do number 8. Number 9, we can do number 9 quick, and then you guys can finish off 10, and that'll be the end of the video. So number 9, in the 2000-2001 school year, the average cost for 1 year at a 4-year college was $16,332, which was an increase from 5.2%, an increase of 5.2%. If this trend were to continue, the equation c of x, which is this whole thing, definitely exponential because of that x, it would be used to model the cost, c of x, of a college education x years from 2000. Okay, sweet. Part A, find c of 4. So this is evaluating functions. What did I just replace x with? I replaced x with 4. So what am I going to do? I want to substitute in 4 for x. So c of 4 equals 16,332 times 1.052 raised to the 4th. You put that in the calculator and you would get about $20,003. And what does this number represent? Well, it represents the cost of college. Again, 4 represents years, and we started in 2000, so 4 years after 2000 is in 2004. That's the cost of college in 2004. And then part B, if this trend continues, how much would parents expect to pay for their newborn's baby first year of college? Assume the child would enter college in 18 years. Okay, this is another easy one. 18 years, that's your x. X is always time. So now we're evaluating c of 18. C of 18 equals 16,332 times 1.052 raised to the 18th. And this would equal about $40,674.54. Okay, you guys can finish number 10, and that's the end of this video.